Hey, happy Sunday. This is PFG Live, the podcast that asks, if you start trouble, do you have to finish trouble? Welcome aboard. We have a bunch of folks in Discord and on YouTube. Let's see. Carl is reporting in with 27 degrees and cloudy with 4 to 6 inches of snow in Rhode Island. We officially here in Windham, New Hampshire, got 7¼ inches of snow. CJ Stevens says hello at 51 and sunny in East Tennessee. Welcome aboard, CJ. Art that makes art. Wes says if they broke the pencil in half, there would be two. Then each guy would have half a pencil. It could happen. Let's see. John Thawley says 63 degrees and partly cloudy in beautiful Orange County, California. A perfect winter day. You could wave at Tom. He's not that far away. Let's see. Evils is reporting 21.0 degrees centigrade inside his lair. Josh, our audio checker, says check, check. Thank you, Josh. The METAR 4, Charlie X-Ray Mike Delta, which is near Josh, says it's 290 at 10, gusting 15 knots. Temperature -13, dew point -18, with a bunch of comments. Dale says it's -23 degrees science and sunny in northwest Snow Mexico. Edmonton of the Alberta. Daniel, welcome aboard. It is 6 degrees C in northwest London, UK. Welcome aboard, sir. Rod, 828, says it's 78 degrees Fahrenheit in League City, Texas. I hate my life. LOL. We love you here. Don't worry. You don't have to worry. Mr. Saunders MW, welcome. You're new here, I believe. 33 degrees Fahrenheit at Nova Labs, also known as Johnny 5 HQ. Tell Johnny he owes me $20. Robert Simpson has joined us. 30 degrees Fahrenheit and overcast near Detroit. Welcome, sir. Test Room 2003. Good evening from Oostkapelle, Netherlands. It's 3.5 degrees science and 86% relative humidity. Let's see. New York Machinist is checking in. 25 degrees Fahrenheit at the bottom of the gorge in Ithaca, New York. Windy as usual. Welcome, sir. Arstead, also known as David, says it's 29 degrees Fahrenheit in central Illinois. Welcome, sir. And I will take the time to say hello to everybody in Discord. We have Josh, DBX, Landvog, Dale, Evils, Paul Morley, Carl Tauber, Thomas Hardy, Daniel F., Pixel, Proteum Machining, David, Rod 824, New York Machinist, Metal Master, E. Perrin, Robin, Chris O., Jeff, and Saunders MW, all in the Discord. Welcome aboard, everybody. So we got guys checking in on YouTube. We're up to 21 concurrent viewers. I want to say welcome to everybody. If this is your first time here, I'm so sorry. I have a couple of bits of news. I have a tiny bit of news. Oh, one thing, the McMaster car catalog giveaway, we're going to do that next week. We're not doing that today. And we will do a random drawing. So next week, random drawing. Keep an eye out for instructions. Josh says, good morning, 23 and overcast at 6 a.m. in Sydney. Say hello to my cousins in Sydney. Jeff Dumas says hi. Welcome, Jeff. Let's see. McMaster car next week. So Robin, who will be here in a few minutes, turned me on to the Stay Bright made by Harris. This is a solder. So I go to Airgas and I say, hey, do you have this stuff? And they say no, but we can order it for you. And I literally look over the shoulder of the guy at Airgas, and there's this thing hanging on the hook. And I walk over and I look at it and it says Stay Bright. I'm like, wait a minute, that's a trademark. So I turn it over and sure enough, it says Harris Products Group. So quick tip, if you're looking for Harris Stay Bright, they have it wearing Radnor clothing in Airgas. So I got myself just what I needed. Thank you, Robin, and thank you, Airgas. Okay, we're going to go over today. Okay, usually we keep it to 1 hour. I promise you we're going to be over an hour. So if call whoever you have to call to cancel all your family plans. However, it will not interfere with any sports events. Any sports events. I promise you that. as we proceed today with two guys and a pencil, the problem process, number one, questions and comments are encouraged. So if you have things you want to say, definitely put it into the chat on YouTube or the chat in Discord. We will see them, and we'll make sure that they get brought in. There will be no proprietary information given out during this event. So this is everything's in general terms. We're not invading anybody's privacy. Trust me, I checked. In the unlikely event of an emergency or a cabin depressurization, we lose the stream to YouTube, which is the most likely failure mode. We will keep going on Discord. We will keep recording locally. We'll attempt to reestablish another stream, but we keep going. Okay, just so you know. But if you see the masks drop from the ceiling, put your mask on before assisting somebody else. CJ Stevens, who said that? Oh, WidgetWorks says like and subscribe. Thank you. Yeah, you should do that. Let's see. Why are some clouds flat on the bottom? Why? Wes? Because they're cumulus clouds, and they've been stoned. Is that a copyright disclaimer for the content too? No. This content is copyright Kinetic Precision in the United States of these here Americas 2025. What else we got? Oh, remember that this problem process is P1. So we're going to learn a bunch from this, and we'll use it to improve the future things. So we will make mistakes, and we're proud of that. Okay, we will talk to that. After whatever we learn during this whole thing, we will add links to the description on the video, and we will probably add it to the links page at pfg.gg/links. And I guess that's pretty much it. So let's see if anybody has any non-problem process issues that you need to bring up that you've been saving all week. Let's have it right now, or forever hold your peace. Are we good on video? Good on audio? Check, recheck, double check. We've got Zoom audio feeding in. We're using Zoom to bring in Tom and Robin, so we'll have a Zoom meeting. You'll see both of them. We're going to have a whiteboard. They're going to scribble on the whiteboard. It's going to be awesome. Everybody ready? Okay, so let's see. Tom, Robin, are you with us?
Yes, sir.
Welcome aboard PFG.Live.
Great, thanks.
You've been here before, both of you, but not simultaneously, which is pretty cool. So today we're doing the problem process, in which we're going to dump a problem on you and look forward to learning how you solve it. So you have full control over the whiteboard. You guys can turn the whiteboard on, turn the whiteboard off, do whatever you have to do. I may have to interrupt to readjust the whiteboard so everybody can see everything. I will tell you before I do it. You guys, how are you guys doing? You guys ready to go?
Yeah, sure.
Okay. So here's the ground rules are simple. I'm going to verbally describe a problem that is a fairly real problem. And you guys are going to have to come up with a way of attacking the problem. Not only do you have to come up with a way of attacking the problem, but this is a real world problem. So it's going to use real world tools. It's going to have a real world budget. And it's got to hit real world specifications. This is actually a very simple sounding problem, but there's a lot going on here with materials, heat treating, machining, potentially other processes. So, Robin, check your audio.
Check.
There you go. Somebody was worried that you were muted, and I know that you were just taking care of your throat. Okay, here's the problem. The problem is customer requests a solution for locating some work holding. It's similar to the taper attachments of tools in most CNC machines, in which, for example, a Cat 40 tool holder has a taper and has a retention knob, and it sucks the tool up, and it, we hope, puts the tool in the same place every time. There are other types of tool holders. Now I'm forgetting the name of the one that's hollow in the middle, that's got the HSK flavor. And then, of course, there's the Big Kaiser, or there's other names for it, which are called dual contact tool holders, where the tool holder has contact on the taper, it has contact on the face. Customer desires a dual contact solution, which is going to look like an inverted version of a Big Kaiser tool holder. So a dual contact tool holder, such that it is locating both in X and Y, but also in Z, and it has some mechanism for holding it that can then be released, and another one can be brought in. Customer has the following resources available: standard machine tools, 3-axis mills, 1 5-axis mill, a surface grinder. You can ask questions later if you want to know if they have other capabilities. A customer has approached other tooling vendors who have offered a solution that would cost close to $1 million. A special tool, multiple axis grinding thing. They don't have the budget for that, but they would be willing to spend a number which is about 1/10 of that. So $100,000 if they have to, but they would prefer to use what they have. Customer suggests A2 tool steel as a material, but they're open to suggestions. And similarly, customer has done hard milling, soft milling. They're comfortable with that. Then they've done some grinding, and they're comfortable with that. But basically, planar grinding is what their experience is with. The approximate size of the widget is the bore size, or, well, let me put it a different way. The approximate diameter of the whole thing is going to be on the order of 3 inches to hold down the other thing.
So this would be the diameter. We would call that the gauge line. Is that 3 inches at the gauge line?
Approximately 3-inch diameter at the gauge line. Yeah. So and then of course there'll be some sort of a hold down mechanism for this thing, which could be could be a flange. It could be something like you could assume it's a flange with hold down screws.
That's a really big holder. That's a 3-inch gauge line.
That's like a 50 taper holder. Yeah.
Yeah. We sure we're talking about gauge line and not the overall of the.
No, I think there's a miscommunication. I think the overall of the thing is about 3 or 4 inches.
Okay.
The hold in mechanism that you're about to design.
So let's clarify this here. Can you see the whiteboard?
Yep.
Okay.
Loading.
It's loading here. Hold on a second.
Is this a work holding use of this versus a cutting tool holding?
Yes, this is work holding.
Okay, so it's work holding. It doesn't have to rotate then, right?
Correct.
But it is going to need some very accurate rotational positioning along with the dual contact for repeatable location of some product that would go on there and need some kind of XY machining on it relative to the holder.
I believe
or the actual.
Yeah. So you're asking, does it also need to reference in rotation? And I believe the answer to that is yes. I'm watching a super secret feed over here, and my customer will tell me if I am correct in my assumption.
So are we saying just approximately that this is 3 to 4 inches here? Like this?
Yes.
Or so when we say gauge line, this is that dimension there, which is a lot different than 3 to 4,
Yeah.
kind of the whole assembly.
Agreed.
So is this correct here?
Yeah, let me grab it. I have a drawing. Let me grab it.
I got the impression from the discussion that this would be inverted. You're showing it as if it was a mill spindle, but I thought he meant this would be
No, I agree with you. I agree
right.
with you. This was just easier for me to draw
Yeah.
this
Oh, yeah.
way.
Understood. No problem. I'm just making sure I heard straight.
So,
yeah, I got questions. So,
so the answer is yes. That's about correct.
Okay, all right, that's fine.
And
just so we understand that. So,
and Tom and I were concluding while you were off headphones that this is an inverted version of what you want. This needs to be flipped.
Yeah.
Yeah. Okay.
So I could walk up to my milling machine table and slap this thing down,
right.
And then so Dale posts a picture of a Jergens chuck. I'm feeding you my camera. Let me feed you guys my the other thing.
Okay. Yep. Ball lock, Jergens.
Yeah,
yes.
ball lock. Yeah. So, my first question, I guess, is there's a lot of stuff already out there like this that's not in the $1 million range. So
the $1 million. Hang on, the $1 million. It was the cost of a super fancy grinding machine to solve customer's problem. That wasn't the cost of the product. The product has to be okay. This is a fair question, and I don't think I answered it. The target cost for the product should be, I'm going to say under $4,000 to the customer.
Okay, so somebody's creating their own locating system similar to some 0 Point or Big Kaiser or one of these, Lang or one of these folks. They're creating their own system.
Yes.
That they want to market and sell.
Yes.
Is that correct? Okay.
Yes.
All right, that makes sense.
It does. Now, what we haven't talked about accuracy. So, whereas some of these very fancy systems, like Dale points out, might claim a tenth or two, this can be have a 4/10 window. So plus or minus 2/10 is fine.
So would this be a repeatability number?
I will say yes.
So if we take it on and take it off, it needs to repeat within 4/10.
Correct.
Okay.
What's the angular error allowed in that?
No spec. I have no spec for that.
Well, that's a pretty critical issue since we're looking at I'm assuming that we're not restricted to a round piece. That's just to give the mental picture. This doesn't have to be the equivalent of a HSK, or it doesn't have to be a round orifice, or is that something?
It does not have to be. The work holding.
So, just to clarify for me, Robin, are you saying so we've got 6 degrees of freedom here, right? And so we got XYZ pitch roll yaw, right? So when you say angular, you're talking pitch and roll and yaw?
Well, I'm sticking with if it, let's just say it was an HSK holder that was inverted.
Right. Okay.
Everything's controlled except the angular, a high accuracy angular location.
Okay, gotcha. Okay,
therefore, that's why I'm keep pounding on that, is because I want to know what that angular is, because that has something to do with, if we used round, we could use a tapered pin type thing, tapered seat, in order to keep that high accuracy, but it might be overkill.
Right.
So I have two bits of information that I think help answer your question. There is a parallelism spec that is 2/10 all over. So over the contact area, it can't be out of parallel more than 2/10, if I'm reading that correctly.
That's a seating accuracy of the flat face type thing, but that still doesn't answer the rotational accuracy needed.
Right. So
you can assume
up until this.
I was going to give you a number to assume, because frankly I don't have sufficient information on that.
Okay, so maybe my question is going to help clarify this. So right now we're working on the assumption that this is a single point. It's a single point attachment. Is that a requirement? So for example, if we had 3 points, then you've just constrained your rotation, right?
It's a single
point. Or even 2.
Yeah, right? We're going to assume a single point.
Okay, so it's this single point plug-in type thing. Okay, yeah. All right. So you're looking at something like a what is that called? A System 3R deal, where you have some tapered. You have a central location, and then you have something that keys in for real high accuracy angular registration too. The trick is, how depending on, so at what radius is this angular accuracy measured at, right? Is it at 10 inches, or is it 1 inch, or what, right? And
we would say it's the extent of the device. So
at a 4-inch diameter, it has some angular accuracy.
Right.
Yeah. Okay.
Or if another way to put it is, if we put the work holder piece of this arrangement in and intentionally rotated it one way and locked it down, milled a surface, released it, intentionally located it the other way as hard as we could, and put it down, and then trammed that 4-inch span, what would that be?
What would that number be?
Right? What would that number be in tenths that it needs to be?
Well, he said 2/10. Well, that was parallelism, right? And so do we have 4/10 to work with there at a 4-inch diameter?
I'm going to say yes.
Okay. All right.
First thought is, why? I would want to know, what is it about the existing systems? Tom's probably thinking the same thing. What is it about the existing systems that isn't doing the job?
Well, okay, good. I'm just laughing at myself. This is somebody trying to create a product to compete with those guys. Okay, so they want something that's cheaper than System 3R, or cheaper than Big Kaiser or whatever, and it's something that they can manufacture with their relatively basic tools, and market and sell, right? So they want to compete. They don't want to buy, right?
But
they want to compete.
I think the place that they're willing to give up is a little bit of accuracy for cost.
Mm-hmm.
That's my understanding from the conversation I had.
Okay.
Does this have to be the locking mechanism has to be available in manual and pneumatic / hydraulic?
Just to focus this, I'm going to say it's going to be mechanical.
Okay.
Or manual.
Manual. Sorry.
Manual. Okay. Manual latching.
Is there a height restriction to the system, meaning the base block that is that's the individual work platens are going to fix into? Is there an overall height range that we have to be within on this for an assembled unit?
2 to 2.5 inches would be desirable.
Okay.
Yeah, that's a bit of space. You got your fixed. Yeah.
Do we need provisions for this to be able to work in a nasty environment? And we have to make sure that there's provisions for the seating areas to be blown clean or whatever. We're going to have coolant and chips around this thing. Does it need to? Does the interface have to be such that
in a standard machining environment, it's going to be coolant and chips and.
So corrosion's a big deal in this, right? So, and A2 might not be the best choice for some of those things. So
why do you say that?
Corrosion, straight up, right? I mean, come on, you've taken your magnet off of your grinding machine, right? Before, what lives underneath there?
I couldn't communicate with it, so I don't know. I'm not sure.
Okay. Yeah. No, I'm just saying that something like a lot of fixtures or tooling that's used in wet environments or nasty environments, 420 stainless, 440 stainless, things like that, right? They're more corrosion resistant. They're still hard, or relatively hard. So, if the surfaces corrode, then you destroy your accuracy, right? So, I mean, it's a consideration. So, yeah. So there should be drainage. It's going to have a receiver hole, right? It's going to get coolant in it, right? So, should be some provision for drainage out of the device.
One of our commenters says carbide doesn't rust.
Yeah, but
so the locking mechanism, or can we say that there will be air available even though it's manual locking?
Yes.
Okay. So just first thought with everything we're saying here, they want a single post type of mount. I'm all in favor of the facial end taper contact.
The dual contact is desirable but if you can make the argument that that's not the way to go, that's why we're here.
And then then all we have to do is add something that's a reasonably accurate rotation alignment piece. Does this need multiple? Is this, a lot of these things are indexable, meaning like a 3R, you can get very accurate 90-degree indexing by putting it on in one of 4 positions. Is there any need for that whatsoever?
No.
It goes on one way, period.
Yep.
Okay. I mean, I've looked at that 3R thing long and hard. It's a really nice setup, actually, and it's got built-in flexures that remove all movement, lock it in a angular and vertically, right? It has good face contact and rotation, anti-rotation, and they're deadly repeatable, right? So my first thrust would be to, examine that a little bit, and how could we make that makeable? I mean, they're pretty proud of those things too, right? So they get a lot of money for them.
How much do they get for them?
depends on the size. But actually, that's a good point, right? So, what did you say was there some threshold cost or sale price or
4,000.
something? What was it? Four
4,000.
4,000. So,
Is that
so
does that mean the one master base and one platen or
Yeah.
palette
Yes.
that would be 4,000?
Yes.
Okay.
okay, well
One
that
the
doesn't sound
only
too bad. Yeah.
making those 3R things is actually stupid simple. Um, I've made those for um situations where we had like a submerged EDM
Mhm.
type thing that was for making diamond rolls, and you can buy the flexure plates from them and the spuds, and it's really just these little towers with the shallow taper that fits into the four holes in the four rectangular slots in the flexure. Flexure's held on with the mounting bolts. The mounting bolts are hard, and they're super simple. The only restriction is that they do not have the work holding um, capacity as far as um, force that any of the other systems have. They're relatively limited in. You're not going to go in there and wail on it with a 5-inch face mill on those things because they have a limit to their stiffness. So that might be the I would be all
The
for it, but
limiting factor.
yeah, the
Yeah.
limiting factor in going that route. But and I don't know that actual uh, system is even patented to any degree that's left to matter on duplicating that because you
Mhm.
got 3R and you've got what's the other people that do basically the
Oh,
exact same thing.
Aroa, I think.
Yeah, Eroa. Yep. Yeah.
Aroa, yeah.
Yeah.
But so
Well, circling back
I
to
mean,
the
those things are, I mean, even the rather large ones of those are not very big, right? They're in the 3-inch kind of square regime, I think, right? And I don't know how big they go up, but that kind of arrangement is actually,
I'm gonna grab some pieces that are that and to
oh,
show
okay.
on the
Yeah,
video
yeah.
here.
Maybe,
so I think the major question is if well the customer was interested in the dual contact approach, and one of the big challenges was how do you do that? How do you make it cost effectively? And
yeah, well, it's good gauging is what it is, right? And if you've done much work with tapers and trying to hold an axial position, using a tapered connection, right? Tapered connections are wonderful, right? Um, they lock up with no play and no movement, and you can transmit a lot of power through them. So they got some kind of cool advantages, right? But making them is tricky, right? Because there's all kinds of stuff going on. So if you're off on your angle or you're off on your diameters, there's a lot of ways to screw them up, right? So, and in fact, there's some tricks of the trade there, um, that you grind with biases in certain directions. Because you can never hit the angle, perfectly accurate, as well as the female part too, right? The receiver part, right? So there's some favored directions to be off, right? And that still allow the thing to work and make a good solid connections. But the tolerances on those angles and those diameters is pretty demanding actually. Robin, I was just talking about the difficulties in gauging and in creating tapers that fit together that have a really good axial location. Um, you don't have to be off by much
Yeah,
to
yeah.
mess that
The
up.
the gauging for HSK and for the Cat 40 dual contact the Cat 40 actually is a lot less sensitive because this angle is steeper, but the HSK are extremely touchy, and the air gauging and masters for those are where all the secret sauce lies. But this is what makes up an Aroa system. This is the spacer shim. This is the actual shim that has the rectangular holes for where the feet go in. This is the homebrew plate made out of A2, and this has the pillars. This is actually for two different sizes. This will hold the larger and the smaller.
Oh, okay, yeah.
And then these are for the feet to go into. And here I'll show you the test. This is a test arbor that was made for this since this was actually used on rotary. So this is a test arbor. This is hardened, and then these thread in with the spacers. The spacers underneath. It gives room for this to flex. These socket heads here, they hold the whole assembly tight, as do these out here. So you put this together, and then you grind and lap these feet to be parallel to whatever you're after, and then you need just a draw bolt that pulls this together.
Right. So the draw bolt's not part of the accuracy there, right? Yeah. So.
Yeah. The draw bolt, if it's sloppy, can influence it. If you're really out to kill, you got to be sure to have something relatively non-influencing, because you can still push on these and influence them. When you start, as soon as you get below a tenth, then you're talking in the realm where any forces in the clamping can influence the way it seats. But anyhow, that's the
Robin brings up a good point, right? Is so how would you characterize, or how much load do you want to put through this thing, right? What do you want to have the ability to do, right? And so you want to be able to mount a 6-inch Kurt vise on one of the pallets and use that like you would if it was bolted to a machine table. And so would that be
I think
an
that would
analog of how you want to use it, or
I think it would be a smaller version of that. I mean, I don't. Okay. It is for milling applications.
Okay.
But
so maybe you're going to put a 3 or a 4-inch self-centering vise on one of these pallets and drop it on this thing and go to town or something like that.
Yeah. But really, the primary question is what system to make and how to make it with available tools, with the available tools in the shop. So with a limit on potential additional investment, which is a question.
Well, the system that Robin just showed is actually is good, right? It's a proven technology, right? And sure, you can reinvent the wheel if you want to, but as Robin points out, that might not be husky enough for milling applications, right? But it also is, you can redesign it with that thought in mind, right? And beef it up. I mean, I don't see any reason why those lugs can't be bigger or more substantial, and I mean, those plates can be laser cut, and I mean, there's no particular precision in in the little thin plates, right?
No.
Yeah. I mean, they're just
those are actually, I think, fine blanked.
Okay. And could they be laser cut?
Is there any concerned about the heat affected zone of the contact edge that hits on those pillars?
Right. So they're okay.
Can I open a whiteboard for myself and work on it, and it won't disturb anything?
No, you have to show us.
Well, I just thought it would save time while we're talking. I have some things. If we're going the direction of the taper, I have some things that.
No, go ahead. Yeah, go ahead and start sketching, because that's why we're here. This is how we do this, right? You start sketching. He makes me think of something.
Or you could do a new one.
You could say new whiteboard.
Okay.
Yeah.
Well, you guys are supposed to keep talking while I'm doing this, or are you guys watching while I'm doing this?
We're intrigued.
We're fascinated here.
Okay. All right. This is a cross section here. This is a way to, well, like one of the problems is that when you have the fits, is this is a cross section center line here.
Yep.
Okay. So here, let's say this is our bearing area right here where we're going to get our facial contact.
Face contact. Okay.
And the problem is that this gets really super tricky. But if we do this, where this becomes a flexure and slot through it, then these can conform to some degree, and you can tune the stiffness and how much compliance you want. But that lowers the accuracy of the seats and the platens to a degree where there's a lot of room for variation there.
That's right. That's very interesting. Introducing.
So it's sort of HSK-like, right?
Yes, yes, but it has got some room for compliance versus being absolute. Oh, one's going to stick first, or in theory, you've got a situation with HSK where you're going to be able to expand the spindle a little bit, but if it's too far off, you're just not going to seat on the face, or you're going to seat on the face and the taper's not tight. So where this gets rid of that situation by having it under the worst tolerance condition, it's going to hit. And if the mating part is a little small, that just complies. The ears just bend in and comply.
Yeah. Yeah, and you can make the that connection large too, right? And pretty easy to add a anti-rotation feature, right?
Yep. Yeah. Anti-rotation would probably be something where you would need a tapered groove and then a pin with a tapered mate, such that the pin would be spring loaded, maybe with Bellevilles of limited stroke, but when you come down on there, it actually seats firmly and holds the taper, and like a lapped fit on there. Or it could actually be a single piece flexure where that wedge that you're using to line up would be aligned.
Pin or a tapered key.
Yes, so a pin would look like this. Taper. Wow, my mouse drawing sucks. And then the mating part that goes on top obviously clears here and sits like this, and then this is spring loaded with probably disc springs, Belleville spring stack to get a substantial amount of force here on the bottom of the pin. The beauty of the pin, the round pin, is that the lateral positioning of the groove in the platens or wherever it is, if it's off, if it's a rigid flexure that does this, where you put that tapered thing rigid, you're going to get edge bearing unless it's absolutely perfectly centered. With the round pin, it just rotates and assures that you get seating on the sides of the flanks.
So are you suggesting that this seats in a that you have it's a pin in a slot?
Yeah, the slot is in
so it'd be like this
in the platen. No, it would actually be the slot. Well, yes, it would be like that, but it would only need to be long enough to account for the flats that are on here.
Right. I'm just exaggerating the slot a bit. So
and it wouldn't. The slot really could be done with a tapered mill. The accuracy isn't really. It's going to seat, and that pin's going to rotate. So, as an example, like to exaggerate, which is a powerful tool to mention this. Sometimes it always pays to exaggerate errors to the point where you can't see it. So a lot of these little things that we talk about, little errors, is think about if it's way up. So picture that slot that you just drew over there, Tom. Yeah. Picture that being an 1/8 inch off center from actually intersecting the center line of the slot, actually intersecting with the
pin, right?
Pin. The round pin would just orient to that angle. It could care less. Whereas is that you with me there? Yeah, but keep in mind, this thing can rotate, so that in the process of rotating, it's going to make the pin have to sit at an angle. So that what would happen, it would be like this. This pin, in order to get the pin in line, the slot would be like this. It would be off axis because it's off center, but the pin would just rotate the flats would rotate to align with the whatever angle that thing's on from it being laterally
Oh, I missed the
misaligned in its
flats.
machining.
I missed the flats on the pin. So,
Yeah.
okay. All right.
Yeah, we're not this is flats, not a round pin.
Right. You don't want a round
Yeah.
or
Because that's
a line and circle
conical.
contact.
It's not
right?
a conical. Yeah.
Yeah.
We have flat on
Okay.
flat.
I missed that part. So, okay. So yeah, and then you can mount the pin, right?
That would be the stroke limiter, right?
Right, the stroke
The socket
limiter,
head.
and
Yeah.
keeps the pin in place, right?
Yep. But gives
And
it room to compress. Yeah.
mhm,
And the
retains
Belvilles
it.
can give you they're real nice because you can tune what stroke and all that with combinations of them
Yeah,
in
they're nice
series
and
or parallel.
compact. They don't take up a
Yep.
lot of room. You know, you need minimal stroke with that. Okay, well, this is pretty good. I
Yep.
kind of like this.
Well,
So,
this is the point where you say, is this worth pursuing here, or should we think about something else before we run down this road? That would be normal procedure.
mhm.
It's say, okay, yeah, this looks like this has merit, but should we say, okay, we can't use this? Is there something else
Well,
before we
so
take
we
off?
call that, do we want to put another horse in the race, right?
Yeah,
And well, when you're brainstorming, a lot of times you want more than one horse in the race, right? And then as you push them a little further along, one becomes kind of the clear um, one to put your effort into. But what happens many times is you'll get a little further and it'll be a dead end on the one you thought was going to be your primary, right?
right.
So, um,
I mean, I think this is good, but and I don't see any roadblocks down the way, but I also know that that's dangerous, and we might spend
well,
5 minutes to think
so
about something different.
in the interest of time here, right? Okay, let's 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 just talk about manufacturability here, right? Because that's one of the requirements, right?
Yep.
Is this has to be able to be manufactured um, and heat treated and then finished and all that, right? With relatively common shop equipment, right? Okay, there's a receiver, right?
Let's see. This is actually that pin actually would be on the far side like this, and then this pin would on the far side of the hole.
Right. So if we're saying this thing is round, right? Um, ooh, not a bad circle.
Nice.
Quit while I'm ahead, right? Okay, so are we saying an angle slot?
If I may draw, oh yeah, you're up there. You're underneath the. Can I get the comment panel? Can I move that thing?
You can zoom out on your whiteboard.
Okay,
Yeah, you
yeah.
can zoom out on your whiteboard,
There we
lower
go.
right.
There we go. I got it. Yep.
There you go. And then let's see, we need a so the central there's some central
Yeah.
locking feature or
Yeah. Pull
whatever.
stud or whatever. Yep.
And then maybe let's see, how would you do that? So you probably won't have access to the center line through the pallet, right? So you're going to have to um, have some feature here where it's maybe relieved underneath, right? Where you can have a lever. Yeah.
I'm gonna move over on the other side
Oh, are you
here.
using your eccentric cross pin thing?
Well, actually, no. The conical, just like some of the uh, boring bar extension things, conical hole. Boy, I suck at drawing with this mouse. and your pin is offset like this. Your actuation pin is threaded that comes in from the side. So that's the dead simple way of getting a pull down that drops in. Since we have the
Oh, so
single key,
it's just driving it into a taper, right?
yeah. Well, it's pulling that down till we seat on our mounting face here.
Right. Okay.
So a lot of tool holder extensions. I think even Kaiser
So
might
you would
use
just
those.
come in, you would come in from the side there. Yeah.
Right. I
Okay.
mean, and that's a dead simple, threaded hole, hardened nose
Okay.
type
I know
thing.
what you mean. Yeah.
Yeah.
Yeah. And you have access to that even when the whatever you got on top overlaps
Yep.
the diameter of the receiver, right?
Yeah.
Okay.
One thing in thinking about cleanliness is this platen could have a lip. It might be something that's like plastic or whatever that's added afterwards, right here and here that goes up, and so that this isn't something where stuff just comes in and falls in. This comes in here and forms like a almost like a labyrinth seal type thing here, where that inherently lets whatever solution falls in here doesn't just run down in to the lowest point. It's got to climb up over the wall and everything to get down in there. Since we need some flexure groove here, space for this to work.
Yeah, and then I would probably add some drain holes or something in that recess, right?
Mm-hmm.
Um,
Another
those
thing,
could
this doesn't need to be a continuous band. It probably would be better if it weren't. If this were just multiple
oh
plateaus,
segmented or
yeah,
something.
segmented so that everything runs off in between them, except where the pads are. That could be another way of doing that. And then the platen itself could just be a flat surface to make it so that the platens you're going to be producing a lot more of than anything else. So you want to minimize the machining features on it to the minimum and do everything you can on the base.
Well, then I would want to put discrete contact points, right?
Yeah.
And that were slightly raised, right?
Mm-hmm. Yeah,
And
that's what I'm picturing. There'd be
yeah,
plateaus here that come up and hit like that. And um
like what?
well, it'd be a pad.
I'm teasing you. I'm teasing your crummy drawings.
Yeah. You know what works good is this tool over here.
Which
This works
one?
good because it's a line tool, and then you just keep hitting it again. You can actually draw straight lines and draw a lot better thing. Hit it again, and if you don't
Oh,
hit it again, you'll be able to stretch it. So like I can adjust this now and then come back here
oh,
and go up. So
I hadn't
uh,
tried that yet.
I
So
should be
okay,
using this since I experimented with that, and you can do a lot better drawing. Just takes a little longer to do.
yeah. Well, no, I think we're communicating here, right?
Yeah.
So I don't have any problem with this um, so far. So let's see here.
So one thing that would be important with this is that this central pin, even if it's bolted on flat, you would put this together and let that this would be a fairly close fit, nothing crazy. But when you put this lateral force on this down here at the bottom, you
Yeah,
want
it's
that
going
to
to
be
deflect
absorbed by
it.
the hole, not the whole system. Otherwise, depending on how tight you tighten it in that axis, it could be shifting. Since these ears are somewhat compliant,
Mhm.
if you put enough force on them, they're going to comply with the forces from the screw. So this needs to actually butt up. Um, and that might be the way you actually do it is put it together, tighten this when you put your pins on, snug this up, and then tighten the upper bolt so that it rests in that seated position, even though the hole is not a tight fit.
Yeah, the other
That
thing
makes
is,
sense.
how about what if you relieve the pin, right? So that it was only contacting the female part real close to the hold down element. You follow me?
Where the pin's putting pressure on, or where
Right.
the conical screw is putting pressure on.
Right. So
Yeah, that would be the
for
only. Yep,
example, you could
yep.
have a so it's bearing basically kind of in line with the pin, right? At that point. So and the rest of this is is relieved, right? Um, almost like like a spherical contact, or not a spherical contact, but a round annulus around that, right?
Right.
And that was bearing just locally, right where that screw was causing that distortion. So.
I'm thinking that I'm going to come over to use this since this worked pretty well. I'm thinking that if we do this and
Man, you're getting fancy on me here, so. Jeez, look at this.
Oh, there we go.
Spencer's going to 3D print this while we're talking.
So
I already started.
Yeah.
what I'm thinking here, just
Hey, Robin,
diagrammatically.
I'm gonna drag this over a little bit because it's
Okay.
a little hard to see. Okay, go ahead. Keep going.
My thought is that this does not need to be a precision pin, and we don't need a precision hole. But in the process of properly assembling this thing, each pallet that you send someone, they put it on the unit,
on the receiver, right?
On the receiver, possibly put a special pin in that does not have a conical surface, such that when you tighten the bolt, it can go up. But you go in there and you actually go to the seating torque that is specified when you lock this thing up. It smashes the pin up against the one wall. Then you tighten the upper bolt over here in this counter bore. Let me get the regular pencil here.
Yeah.
In the counter bore
that's
locks
holding it in place.
Right. And that locks it in place in the orientation with the master that it's meant to go into. Now, that's all fine until you have to do multiple masters. This only works if you have a master that all these things are going to go into. If you're going to go from machine to machine, then that's out the window.
Yeah, exactly. And and that would be certainly a desirable feature, right, of the system, right, is that you could have multiple receivers on the different machines and
not worry about it.
Take the part around the shop, right? And that's one of the beauties of the 3R system is that, once you establish a datum, right, you can move from machine to machine and it repeats within, it's kind of sub-micron, I think. Right. So,
which brings us back to maybe your idea over here is good in the sense that you have a very small axial area. Even if you made it cylindrical, you have a very small axial area that has to be accurate such that it doesn't bend and cause issues with influencing the upper pilot.
The rest of the system, right?
Yeah.
So let's So let's talk about the tapered seat for a second there. So were we saying that that's like castellated or segmented?
So maybe like 6
or something.
Yeah,
6 or
maybe 8 slots. So you'd have 45-degree sections that could flex.
Yeah. Okay.
You're not just flexing now, are you?
What's that?
Yes. Oh, it was one of Spencer's jokes.
Yeah.
Or pun.
We'll get back to it later.
Yeah, actually, the slots don't need to be very big, right? Yeah.
No. And it might be that in order to make them easy to manufacture, it might be that you actually do an arc. Let's use this here and go in with a cutter. I think I can move this now. Go in with a Woodruff cutter type thing where you can get all the way down to the bottom to get all the flexural area. Obviously, this would have to be bigger. Oh. Yeah. Delete. There we go. There you go. You have to have room for your shank, but you get the idea where this would not be a problem to put these reliefs in. You wouldn't have to EDM it or anything crazy, but you'd be able, if you don't take it all the way down close to the bottom here, you're not gaining anything. If you don't get this slot, the relief all the way down to the.
Yeah. Well, in that case, what I would do is I would make the slots wider so that you could mill it, right? And so they don't need to be 1/8 of an inch or anything like that. They could be 3/8 of an inch, and now you can just mill those slots.
Yep.
with a cutter that's got a little corner radiuses on it so that you don't create any weirdness down there,
Yep,
right?
exactly.
Yeah.
Yeah, you don't want any stress risers.
Right.
And what material do you think you're in at that point? What material?
So,
Well, they said they liked A2, and there's nothing wrong with A2.
yeah, I mean, other than, that it will rust in certain environments, right?
Yep.
And but it's readily available, non-distorting, so you could probably machine this net shape, right? And since you're allowing a little bit of adjustment in the tapered seats, right? And maybe the only thing that you do is grind the top when you're done, right?
Yep.
So you got a nice flat thing, and that thing's it's got a pattern of holes in it or whatever, right? You can get them blunt. Well, let's see. There's a good point. So okay, wait a second here, gentlemen. What?
Machinability of the top plate. Is that where you're going?
Yeah, that's where I'm going, right? And
Yeah. Good point.
so because to
So,
me that's a desirable user feature, right? Is hey, I want to mount this wacky Chinese vise I have, right? Or I want to put I don't know what on there, right? And so you couldn't predict what patterns they want, right? So maybe this flexure thing is something that's attached to. Let's just go on left field. Let's just say this piece here is aluminum, okay? And now this whole this whole module, I'm going to call it a module just for now, right? I'm putting a box around it. Now that's made out of tool steel, and it's you attach it to whatever you want to attach it to. So
and
now, go ahead.
it would have to be wide enough here. I know you're implying this anyhow, but it would have to be wide enough here for whatever bearing area we chose to
Sure,
be for
sure.
the facial contact. Yep.
Exactly, right? So it's now so that's all heat treated and nice and has registration features on it and all that. And then, sure, you sell the platens too, blank ones or whatever, in mild steel or aluminum or whatever, right? Now it's a consumable. That's another upside if you're selling the system, right? Um, and so now you
And
have this.
and there's
So
there's
the
nothing.
receiver has to be built well,
Yeah.
and then you have to have a good way of attaching the tool steel flexure part so that it's got a reliable connection, right?
Yeah.
So, but that doesn't sound too bad.
No, and the whatever the width of band is that we do there radially for the facial contact, that would just need to be wide enough that it would also contain the groove.
Yep. So
And
exactly. So that piece has
yeah,
all those features in it,
yeah.
right? But it's low enough and that you can attach. Let's see, how are we doing on height here? So
Actually, you know what? If we just where you drew the shortened version of it height wise, if you just extend that out further, that would give you room for threads that could actually go clean through out there in that realm outside of the engaged area, and that could be where they put their mounting bolts to
say that
just
again.
flat out here in this realm here where the um we
Yeah,
stopped
it's got
here,
a
but in
flange on
theory,
it, right?
yeah, it's got a flange, but we could go out. This could be wider, such that you have a bolt circle out here where you've got plenty of room for threads
Yep.
to go clean through and through tapped instead of blind, and then they could
Right.
just
So
bolt on.
you thread the tool steel part, and then your disposable platens or counterboard or something, right?
Right. Yeah.
And they go on and off of there, right? And those don't have to be like super accurate, right? Because they're going to get faced off and twiddled with or whatever by the user, right?
And then the only thing we'd need to do with the way we're doing it here, I realize we're not implying these cross sections, but we would probably end up having this. This would not be strong enough in itself
No.
for this bolt. But if we make it part of the fixture such that you can put your fixture plate on, but you have to relieve the counterbore for the bolt to go through this and give minimum thickness that this plate has to be, and then let that plate also distribute the forces, not just this. Because this would just diaphragm here at the way we've got the proportions we have pictured here.
So it's
and that would also decrease the cost of the amount of tool steel that you're using for that.
Let's see. Could you hold it down a different way? What else could you do there? I don't know. The central, as soon as you start moving to the outside, it really needs to be concentric there. So.
I just had a wild thought of I'm going to draw a inverted version of this.
Where
we
just flip the whole thing over?
Flip the whole thing over. And then the other features could be we could give people the dimensions for those other features. And they could, even if they didn't harden them, they could simply bolt, put the required features in there, the taper, and that you would give them I'm just going to flip it over. I'm going to do a flipped over version. And
just scoot the whiteboard over, and
oh, that's true. We can just scoot it over.
You can just drag it over and have a fresh spot there.
So let's see here.
Tell me when you've made at least one little mark, Robin. Then I'm going to re-zero you here.
Okay. Just making sure I'm thinking straight here. Okay.
Tell me when I can re-zero.
Okay. Hold still for a second, Robin.
Yep.
Hold still. Go ahead and move, Spencer.
So you're right there, right?
Yeah. He's off to my left.
Okay.
You good?
Did you do it?
Continue.
Oh.
Okay. So let's see. This is going to be this way down here. External like this, and make this larger so that let me erase this while we're here. Oh, I know what I need to do.
You can just draw one half of it.
Yeah, that's true too.
It's a revolve.
Yeah, it's a revolve. Duh. Oh, you mean you can do that in SolidWorks? Wow. So pen again. Here we go. So this would be the external. This would be the base.
Yep.
And then, in theory, you could machine your own platens with the correct taper at the correct diameter. But this leaves a lot more meat for whatever we put on here. And this thickness can drop in once it's past here. This can be up like this, over, and then down in, so that this is thicker in the center, so that this doesn't diaphragm.
Yeah. And now you can just attach your pin directly.
Yeah.
So.
Yeah, and then this gives you full bolting distance here. And you got this area to bolt in and this area to bolt in, so you have quite a lot more area that you could.
Yeah, I like this better because now your seating features are up out of the muck too, right?
Yep. Yeah, they're up. Yeah.
And they're up, and you just blow them off, and they'll be clean, right?
And this could actually be filled with an elastomeric in here, such that it wasn't a cavity that wanted to fill.
Oh, good idea. Yeah.
That and the other slots could be,
you could just poke an O-ring in there or something, right? Or a couple of O-rings.
That's true.
Yeah.
So now we still have we could still do the pilot, and this gets rid of this huge wasted area here where we had all this length.
Right.
And this
does it lower the overall setup?
Let's see here. Let me erase, or can I erase just parts, or is that the whole line going? Oh, okay, that works pretty good. So let's draw this a little more accurately here. There's that. Let's put a center line in here just for the fun of it. And then this area here becomes where you need your cross hole here for your actuation pin. Right. And then this makes this spud much shorter and has much less moment
nice
arm
and
than
stiff
this
now.
did.
Yeah. I like it. Nice. Okay.
In theory, this could float. And then we get rid of that problem. We could do this where this is like a shoulder bolt kind of thing where we come up
it's got a little bit of vertical.
Well, yeah, like basically, if you put a shoulder bolt in here that has clearance, and like a hardened washer or whatever, such that this has room to laterally clack around, and then the accuracy of that thing going in the hole is irrelevant. It just goes back. It hits the back wall before it starts to pull down, and then once it hits the back wall, it pulls straight down and should be relatively non-influencing. In other words, this would have clearance here for the bolt to be able to flop around, but the still actuate with the pin where the conical hole here is here.
So it's kind of cam lock-esque, right?
Yeah,
like a cam lock, right? So
I mean, in theory, you could put an eccentric in there, but the that gets tricky on tolerances of making sure it's in the right segment. Like the cams on a D1 style chuck, they're sensitive to having just the right amount of preload as far as
you only get
force
half
they put
turn increments on them.
Yeah.
So
Where the tapered cone here would be probably a little better. And there's probably ways to improve that pull down mechanism, which I mean isn't important now to completely nail down, but I think this is functional.
Okay, so let's see. What do we got? We got
so these could be hard turned when it talks about machining. If they have a CNC lathe and CBN, they could hard turn these surfaces.
Yeah, as long as they were roughed in when they were when it was soft, right? You wouldn't want to hard turn that little flexure groove, right?
Oh no, I meant after heat treat. I meant when it comes back from heat treat, just skinning the actual important surfaces. 10,000ths cut on the material.
Okay, so let's talk about parallelism here for a second, right? So if this is one of our flat registration feed surfaces, right?
Where are you? I'm not seeing your cursor.
Oh, really? Do you see my X here?
Oh yeah, wait a minute. X. Oh yes. Okay, I'm sorry.
Okay. So so this is one of your flat registration surfaces, right? And this is where it sits on the machine, right?
Yep.
Okay. So we want those pretty parallel, right? So they could rotary grind that pretty easily, right? So,
you could do your hard turn on this and the socket, make this upper piece as a fixture of this. You've done this, and you grind this fixture piece so it's dead parallel on your grinder, and then you just put it on the grinder upside down, and you threw these on and just flat grind the backs.
Oh, you just do the backside one shot.
Yeah, after you've hard turned it.
So you're going to hard turn down the taper and across the flat.
Right.
Okay. So you got a clean surface, bolt it down to your fixture that's on the grinder.
Yep.
And it's just a big flat surface you got to grind.
Yep. Yeah.
Or
and you could even have multiple
right?
stations there. Yeah. Because basically all you're doing is you're having a platen here that's got the mating surface in the pin, and you just drop them on and grind them.
Right. That's pretty good. Yeah. And hard turning those, they'll be pretty good. I mean, they hard turn tool holders. They're not the best tool holders you can buy, but it's a good compromise, right? So.
Yeah. And if you have a surface grinder and you really wanted to make these, getting a spin table and getting a means to dress the side of your wheel with the cone angle, it would be pretty easy to just actually
rotary
also
grind that.
Rotary grind them. You could grind the face and the taper at the same time, and just go from there.
Where do you get? Who makes spin tables for grinders?
Robin.
Well,
it depends.
That was a leading question, I know, but
right.
But I mean, if a dude just wanted to go get a spin table, what would he do?
There are companies who make them. I can't think of the one off the top of my head. I talked to the guy quite extensively.
Imperial, Newbold, Herman Schmidt. We have
those
comments coming
I'm talking about a more a heavier duty spin table.
Yeah.
Like professional instruments. All those things are wonderful, but they're a very niche item that requires this right kind of care and all that. I don't suggest them for general tool room work.
I don't think those guys are in business anymore. That one that I sent you, Robin.
The one you sent me. Yeah.
I can't think of the name of it right now.
I could go out and look.
Yeah, you're probably only 10 feet from it.
Roto Grind.
Roto Grind, yeah, thank you.
Yeah, I think a version of Roto Grind still exists.
Mm-hmm.
And
yeah, it's a pretty common operation.
Yeah, it's like a $6,000 to $10,000 item, but 50,000 or 50 million is all you're going to get. If you want more than that, then
yeah, you got to go.
You have to roll your own, or you have to,
or your phone has to ring, right?
Yeah,
your phone has to ring.
So let's see. Okamoto. Dale says Okamoto has one. Kaiser Wilhelm says Pennico has one. I've never heard of Pennico.
So yeah, you can get one.
Yeah,
but that would actually be nice to grind that taper too, because you're just going to get a superior finish on it, I think, and that's going to be a sliding contact with the other parts, so nice and smooth would be good. So
yes.
So you're imagining a lathe, a grinder with a rotary table,
rotary spin fixture, rotary grinding fixture,
grinding fixture.
What else do you need here? Normal mills and lathe stuff, right? You got some small turn parts.
Let's talk about heat treating. What do you see as the heat treating schedule?
Vacuum hardened air temper.
Yeah.
But you would do so you're gonna hard turn, you're gonna rough turn everything, mill everything soft, and then send it out for heat treat, and then you're gonna come back, skim, hard turn the critical areas.
With the spin table, there won't be any hard turning.
Okay, so if you go spin table, everything becomes hard a grinder operation.
Yeah, it's just all done. And there's some advantages to that, right? So you just finish it, and then you gotta surface grind the machine side.
Well, that can be spin ground too. And actually, if you're out for real super parallelism, I mean, they only ask for 2/10, but it's much easier to get parallel parts on a spin table. Yeah.
I love it. I love it when.
So there's two surfaces you have to grind. So
I love when you say,
and then you don't have to take your spin table off, right?
If they only want 2/10, I mean,
it's pretty wide open.
Well, yeah, that's why we're here, right?
That we are forgetting that if we want the mating part to be hard, there's an internal taper on it. But I think you could easily get away with that being hard turned. Mating with the ground what do you call it, base block taper, and in some ways that having a little more tooth lubrication wise is actually better than two super shiny surfaces.
Interesting.
Depending on the application. Yeah.
So let's go back to the So we've inverted the whole thing, right? Let's say we want hard on hard repeatability here too, right? So you're going to have this, what are we going to call it? A hub or whatever that you're going to attach your whatever platen you want on there. Or do we already have that?
I think that's the piece we have on top now would have threaded holes in it that you could mount whatever you want on top
Okay.
of that.
All right. So
Or
that's hard. That's hard too
yeah,
then. So yeah. Okay.
another possibility there if you
Because I
want to
thought
get
we were talking about it could be soft and they could make it themselves. But to me, if you're going to market a product, right, you give them everything that they need, right? So they can just buy it if they want to, and they don't have to interrupt their production to make things, right? So I know that's how
So,
we operate. We don't screw around making stuff, right? When you can buy soft jaws off the
yep.
shelf, for example, right? So small
So
shops do it
in,
themselves.
induction harden the pallet surfaces, the cone and the flat.
Mm-hmm.
Just induction harden those two surfaces so the rest of it's machinable.
Yeah.
Whoa, that's fancy.
And we have to worry about distortion.
Yeah, it'll distort, but you're going to grind the mating
You're going to hard
surfaces
turn
that have,
or you're going to grind.
well,
grind
either
in the
one, yeah.
Yeah.
You're gonna get whatever it is going to distort. It's going to dish.
Yep, because you're heating
because
it
of the
on one
expansion
side,
of
right?
the A2 is going to expand roughly a thousandth of an inch per inch, and that's going to, and it's all on basically on one side, so it's going to cone a little bit. But you don't really care, and if you grind it in the type of fixture that doesn't constrain it, meaning it lets it while you're grinding it do what it wants to do, that all the other material removal will not cause any issues.
So okay, that's a good point because now you can switch materials though too if you're going to induction harden, and
yeah,
you don't have to make the whole thing out of A2, right? So now your material costs could go down if you use what I don't know 8620, okay, which
yeah,
is
but that
considerably
needs to be
cheap.
case hardened though. That has to get the carbon added to the surface before you can harden it. Whereas the A2 can just be induction hardened, period, or some other
Okay,
steel that doesn't need
well
case hardening.
the 8620 machine's really nice.
Mm-hmm.
It's cheaper than A2
Yep.
by a lot. And well, what about 4140, for example? I don't think it gets hard enough, surface hardness high enough.
I don't think so.
Yeah, it's only going to get up in the high 40s, probably something like that, right? So for these contact, go ahead.
Go ahead.
No, I was going to say for the contact surfaces, you want them pretty much as hard as you can get them, right? So,
Now there's nothing wrong with 8620. You just have to see what kind of typically when they want to mask areas to not get the additional carbon, they can copper plate them.
Yeah, but do we care? I mean, just case harden the whole thing, right?
Yeah, but now you can't drill through it. Now you can't drill from the upper surface.
Oh, you're right. You're right. You're
the purpose of the induction was to only get hardening
part, right.
at the
platen. All right,
yep.
Let's label these damn things here. So let's see.
But if you make a platen with an array of holes, you give a good choice of holes, then you don't have to worry about the end user drilling through it, right? They have holes that can attach to it.
Well,
that's not as good as a blank slate.
To me, if I was buying one of these, putting my own holes in there might be, I don't know. You could do it both ways.
Yeah, I would definitely vote for the blank because what having nothing in there is almost better than having a standard pattern that you have to work around. This would work, except the device I want to put on, these holes run into the existing holes.
Yeah, exactly. Yeah.
And if you find out from the market that no, we'd like a standard, but what pattern is that? That's the hard part. Yeah. What pattern do you want to put in there?
No, we have to put some pattern in there, right? Or we want to put some pattern. That pattern's almost irrelevant because we're just providing a place for them to attach their piece on, right?
Yeah, but that I'm picturing that piece being like a vise. You don't want some intermediate plate. You want to go right through the
Yeah.
vise directly into this plate. No, no plate on first before you can put the
Hmm.
before
Yeah,
you
it
can put
keeps
your
the
other
thing
piece on.
lower. Everything's lower, nicer, right? And
And it might
okay,
also be that you could make these in different thicknesses. Here's the minimum. Here's one that's thicker that you might want to machine into the face of it like a almost soft jaw, or
okay. All
you
right. Well,
want
then
more
you're back
thickness
to
for.
induction hardening there. So just so you can localize the heat treats, huh? Yeah, that keeps the whole thing lower, right?
Yeah.
Yeah.
But here's a question: is induction hardening that adds complexity in the manufacturing because you have to have a way to march around that thing with your induction heating source, whereas in
This you,
through
I'm
hardening,
picturing you would pay a service to do this. This is
Yeah,
not something you would do yourself.
would
in-house, doing your own heat treating in-house is a waste of money.
Yeah.
Because if you go to some place like Solar or Thermofusion or one of these guys, their investment in capital equipment is massive and they have control of the process, right? Sure, it's fine to have a little furnace to do little parts, onesie twosies of things, right? But it's not the business you want to be in.
so my
Um,
And
question is really let's assume that all heat treating is going to be done by an outside vendor, which I know Robin is a big fan of, and we've seen results that are awesome. But if you go to them and you say, "I want you to induction heat this area of this part," versus throw this part in the oven and make the whole thing this
it's going to
hardness.
be more
right,
expensive than standard heat treating, sure, or
Okay,
bulk heat treating, right?
yeah.
So
I mean
there's
you'd go to,
the prices of heat treating
you,
is quite reasonable no matter how you slice it.
you
But
go to a gear manufacturer that does this stuff, that has a lot of rotary induction and quenching stuff, that this would be normal procedure for them. Let's say they're doing a induction hardening of teeth on a face gear. This would be something to be like, huh, no
oh
problem.
yeah,
Yeah,
we
we're going
got
to charge
something
you.
right in that
Yeah,
regime, right? Yep.
we're going to charge you for your coils, the custom coils, and that, and the fixture that we're going to spin it on, and then we could care less. We'll do 1,000 for you, X.
All right, let's talk about some sizes here. So we're going to center line. This is a radius, right? So we were saying, what were we saying, 4 inches or something? Where's my notes here?
3 to 4, I think, was the.
Four, yeah, more the merrier. Like four seems kind of small, huh? 4 inch diameter.
Um, I would think the 4 would work for a lot of people.
go with four. Go with four.
Go with four.
Go with four.
So all right, so now the question is, okay, is that the base? Okay. Do we say it's a 2 inch? And now the platen can be larger.
It can.
Yeah. So you offer some platens, 4 inch diameter, 6 inch diameter, whatever, right? And it has the same features in it, right?
I'm
I can see having a lip could be have some advantages too, right? So,
I'm I'm picturing the platens being available square,
oh yeah.
because that would be much more conducive to think a lot of milling stuff relative to fixturing and all that. So I would think, my guess is that square would be more popular than round, even though round could easily be available. And the machining of the upper one is just the flat surface in the conical hole. So you could care less whether it's square
Hmm.
or round.
What about the base, square or round?
Well, square would give you a place to put 4 mounting bolts in the ears outside of the clamping realm. So I'm
Hmm.
picturing that square
Okay.
would let you
So
put a
have
bolt.
an ear off here like
Yeah,
this, right? And then
yeah,
a hole.
yeah. And
Hmm.
then maybe places where you could put a toe clamp if the holes don't. Uh, you could put a toe clamp on top of that if your holes don't line up in your particular case, and a toe clamp would work.
So you could have a let's see.
Same place where you've got your corners, the four corners. You just wouldn't put a bolt in the hole. You would use a strap clamp on top of
Right.
the
Okay, like this, right.
You need to scoot over some
Okay.
sensor.
You ready?
I can't see the left-hand side of the.
I think you can you scroll the right word yourself, I think. There's a gray bar down at the bottom.
Let me see here. Where's my cursor?
Use the hand. Go
there we go.
And just drag
I
it.
have one of those. Oh, okay. I have one of those mouse that goes to sleep after a while, and if you don't click it, it does. The mouse disappears.
So you can toe clamp down to these ears if you want,
Yep.
right? And put it wherever you want. Okay.
And that might, I'm not sure, but the material might actually be cheaper in rectangular form than the round, but I'm not sure.
Are we
in general?
We're back at A2 then, right?
Yeah, only because of needing some. It doesn't necessarily have to be A2, but something that is what do you call it? Induction hardenable.
Mm-hmm.
Really there are tool steels that are ideal for sliding contact like this, like 06.
I never used 06. Yeah,
it's they're tool 06 and
graphitic
I think
or something
A10. Yes, free graphite. They're graphitic.
Okay, yeah,
and they're meant for places where you got a lot of sliding. Probably overkill for this, and availability is probably not as good as A2. But yeah, those are all tweaks. I mean that the next round of refining would be all that kind of stuff.
We're starting to get off in the minutia here, right? So the okay, it's not bad.
I thought you were going somewhere.
No, I was thinking about the steels again, right? And I've used a lot of 8620. It's actually nice stuff, right? But and it's cheap, and it really gets a hard case on it, and there's usually plenty to grind to mess around with. But
how deep a case will they typically get on that?
I think you can get 60 thou on 8620 if you work at it, and maybe even deeper. Actually, let me take a quick look here.
But does that imply that like 50 is easy?
My Earl M. Jorgensen.
Yeah, it's really how much you tell them they want, and it depends on how long it's in the carburizing environment to absorb the carbon into the surface. 8620 is great stuff.
Tools on this and nitroloy it and
Well, it's a cool design. I mean, you could make this design in all A2 if you wanted to, and you can go 8620.
One of the beauties of A2 for the base is its super stability when vacuum heat treated.
Yeah.
I mean, basically those things are going to, other than the thousandth of an inch per inch expansion, which you can account for, it's pretty much just sits dead still.
Bomb-proof, yeah.
8620 is good, and I mean they're used for gears all over the place. I mean that's like your primary gear steel.
Yeah, it moves around a little bit though.
Yeah. Any case hardening it has a tendency to pillow where the core doesn't shrink as much as the outside. So if you harden a 1/2 inch thick plate, it's not uncommon for it to be 1,000th of an inch or more thicker in the middle than the edges. That kind of carrying on. So I think anything gained in savings in material costs go out the window on the. From my experience, go out the window on something like this where you'd like to stand still. Now, that's not the case if you were doing the platen, and you could selectively. It might just be that the platen could be as simple as bolting two of them face to face when they do the carburizing. Then the carburizing can't get to the two faces that everything else does, and let them go ahead and quench them just like that. You take your bolt out and you've masked the face so that it's machinable.
Boy, that sounds
that's
like an
tricky.
awesome idea.
So according to my thing here, they can do like almost 80 thou.
Wow.
Yeah, but this doesn't need that. You just need to would need to provide enough for cleanup on the grinding
Yeah.
and
One of the
whatever
things,
distortion happens. So yeah.
So
one of
if
the things that would be
implies
good
that
about the 86
Take
would be
your
good
turn.
about the 8620 is that on the base, even though we were sure that, we think that the distortion effects are going to negate its value there, things like that flexure, having just enough case of maybe 20,000 stick case, one of the advantages of the case is the nice ductile core.
Yep.
So
Yeah.
something that flexes like that, that's an advantage. I do a lot of hydraulic expanders out of A2, where they get stretched ridiculously, expanding to grab parts and go through, hundreds of thousands of cycles. And so it's not a problem. Typically you would, that would be tempered like in the 48 to 53 range for that kind of action, but I don't think there'd be any problems on this. First of all, this isn't cyclic, not rapid cyclic.
No.
And so I don't think there'd be any problems there.
And you're well in the elastic range. So even unheat treated, right? You're well in the elastic range, right? So it's you're not deflecting it that much. You don't want to, right? All you want is a good intimate contact, right? So,
and then the if anybody knows what a Freshetta V-ring seal looks like, that could be part of the base or a custom version of that, where when it sits down on, there's actually a Viton lip seal that comes up and hits on the bottom face and keeps stuff from actually going inside underneath.
Oh, so you'd put it out in this area here or something like that?
Where's your cursor? Where are you? Oh, there. Okay.
Yeah, right in this area here.
Oh no, I'm talking about like right in. Oh, there you are. Okay, right here. Where let me get my cursor there.
Go ahead, you mark it.
Then that you're talking about right there where that is?
Yeah.
Yeah. Okay. Yep. Exactly.
And it just deflects down and keeps stuff from blowing under there, right? And
I'll attempt to draw one here that if people aren't familiar with the cross section.
You can put a dumb O-ring in there too, right? And
let's see here.
Even a simple O-ring would seal that. Yeah, I know.
It kind of looks like that. It sits on there, and then this lip conforms this way.
It just pushes down,
and it literally just stretches on. And I'm thinking there might not be room for that, but really it depends on. We could make room for it and just reduce the radial area for the facial contact. But yeah, those are all tweaks that once you get into SolidWorks, and this
you
is
see how much room you have to work with.
Yeah, this is really good in general, and Tom and I both know this is where you speedily do this, and then you go to SolidWorks and you start modeling and you find stuff. Oh crap, that looked a lot different when we were just sketching it. And
I thought I had tons of room.
Yeah. And then you move things around and do tweaking to get this all to come out in the wash.
So let's do a quick recap. You've got a structure that you really like, and there's a lot of cool features you came up with. You've got the metallurgy pretty well sorted out. A couple of choices. You've looks like you've nailed the requirements. You're ready to go to CAD at this point, right? You would now sit down and start.
Oh, that would be the next step, definitely. Yeah.
You start CADing this.
Yeah, then personally, I would look at available material sizes, right? You want to get in the sweet zone if you're going to build a product, right? So there's some tricks to that, right? You don't make it exactly 4 inches, you make it 3 15/16 or whatever, right? And so that you can use 4-inch material or whatever. So those are the kinds of things you start looking at, right? And refining those details. But definitely a CAD layout, a Sanity CAD layout, right? it's a couple of hours in SolidWorks or wherever, right? And you're either feeling warm and fuzzy about it, or you got some problem that you have to address, right? Well,
Is this? Hang on, I think I know who this is. Yeah, it's Adam. Okay, so Adam,
Adam who?
Adam Demuth says
Oh,
laser hardening might be worth looking at for the selective zones.
sure. Yeah.
That's an interesting idea.
Yeah, there's a company that's on Instagram that I follow that does some wild laser hardening. I think it's actually called Laser Hard, I think.
Okay.
If you just want to try it, you can use Robin's method. Just run your TIG torch over it, right? So,
yeah, it works.
Whatever
it does
takes.
work, right?
So
one thing that I would think that to improve on, even though that cone thing works where it's off center and pulls in, it's a very concentrated load. So doing something where you have a pin with a wedge shape where it goes into a slot in that pin, so you get facial contact of two planes for that pull down, would be one of the things I would attack before we went to production or any further in the design.
Well, you want to build one and test it too, right? So,
well, let's talk about that. In the normal process of coming up with a design and then testing it, how many units would you build, and what would you do to them for testing your design out?
Honestly, I'd 3D print this to start with, right? Certainly.
Yep.
No, I mean, come on, right?
Idea.
It's you're gonna learn a lot from that, right? And you can even add, so you could use your 3D printed version of this with a metal pull down stud and all that. You could even roughly test that, right? So using the 3D printed version, right? So, but
we'd have to find a 3D printer somewhere, but
yeah, and somebody that knows how to run one. Right. So
that's a great idea.
If you have a bamboo printer, you don't need to know how to run it.
Yeah.
I'm proof of that.
That's right. It comes with an operator, right? So,
yeah.
Almost.
I nervously went into this new material this week, this ABS glass filled, and was delighted to it. I shouldn't have been nervous. It worked.
It just worked.
It just worked. Yeah. Very nice results.
And that's one of the beauties of the 3D printing, right? Is you're going to go, oh, well, I can just add this feature. I want a groove here, or a radius there, or something like that, right? And you're not committing to tool steel or hours and hours of machine work, right? So
this is a really great point. Okay, this is a design of a thing that is about as far from being a plastic thing as possible. Yet, 3D printing it would contribute not only to the visualization of the part, but practically. Yeah. I mean, it's touching.
Well, and even preliminary testing, right? So you make a base, right? And you make a couple of platens and glue a ball bearing on there and put it on your surface plate, and you can just do some dumb repeatability tests in plastic even, right? So and just see how it kind of behaves, right? And so yeah, you can learn a lot just with literally a wooden model almost, right? So
I'm sorry, the W word, I didn't quite. I'm sorry.
Wooden model.
He probably would.
Yeah.
And don't forget that one of the things you can do here also, just to save time, and that is, I would probably model this thing as is, and then I would do one cut extrude that whacked off 3/4 of it from the center line, so I only end up with one quadrant of it, and print that quadrant, which would show all majority of what you want to see. And then once you get that, I'm happy with that, then save some filament and carry on from there.
That's good point. Yeah, you don't need to do the whole. Yeah, how long would something like this take to print? This would be six or hours or something, right?
I don't even think it would be that much, but
Oh,
Yeah,
okay.
it'd be a few hours.
Depends on the density, right?
Right.
Yeah. So what about this angle here, Robin? This
Where are
needs
you?
to be as
Oh, that's something where you do the math and say, okay, for the amount of flex, you would do a beam calculation of that thing, cantilever beam calculation,
of
and
this
say,
part,
okay,
right?
yep,
Yeah.
right there, and or actual finite element of that, and say, okay, how much can that flex and stay within a safe realm? Half of the yield point or something. And then that radial amount, you could say, okay, if that's that much, we can afford to leave X amount of diametric variation of the mating taper, based on the base thing being having zero, tolerance on there. But basically,
what I was getting at was, I'm following you, and I totally agree, right? Is we want a self-releasing angle, right? And
yes,
but we also, so this is what
it doesn't have to be self-releasing, because you could put a Belleville
hmm.
stack here, captive
That pops
Belleville
it up.
stack, that would push it off if it turned out that a shallower taper would be more advantageous for all the other things. I would avoid that if I could.
So you'd
But
avoid the self-releasing?
no, I would avoid the Bellevilles if it wasn't
Yeah, it's just a
self-releasing. Yeah,
complexity that you might
yeah,
not need,
exactly.
right? So
I just want to clarify, because there may be people listening that don't know what a Belleville washer is, but we're basically talking about a wavy washer that is a planar spring, essentially.
No, it's a disc.
it's a
It's a
disc.
round conical disc.
Oh, the conical. That's the Belleville is the conical
Yeah.
disc. Okay.
Yes. Yep.
So it basically is
So
a spring in a
Yeah.
in
It's
a, in a
what's on the
small area.
drawbars of all your mills. It's a whole
yeah.
stack of Bellevilles that generate a huge amount of force in a very short travel.
So here, I'll share my screen real quick. Oh, can I share my screen,
You should be able
Spencer?
to. Yeah.
Okay, I'm sending a request to you.
Oh, there it is. Allow.
Okay.
We're doing it live, folks.
Oh, okay. We got to turn off the whiteboard here. How do we turn off the whiteboard?
The big
here?
red X. I could do it.
Where is the big red X?
I'll close it.
Oh, okay. There
Now
it
you
is.
can
All
go
right,
ahead and share screen.
So here's a Belleville spring here, and can you guys see that?
Yep.
Yeah. So it's dished, it's curved, and they're very compact, and you can put them together in parallel or serially to vary their spring rates and characteristics, amount of travel or amount of force. They're really nice, and if you need high force in a small space, and their compactness is one of their big advantages. So
Yeah. The beauty of that is you can pick something that's in the realm and say, okay, I need X total force plus or minus something. You can actually pick the spring that you'll use either in, and your stroke matters too. If you need a lot of stroke, then you have to do in series. Parallel just means you stack them on top of each other. It's cone on cone on cone, same orientation, and the force just goes up and up and up, but the travel hasn't changed at all.
right.
If you
Same
invert
travel.
them, edge to edge and tip to tip, back and forth in series, then the force per spring doesn't change, but you get more and more travel.
You
Well, you
double
can
your
do
travel
all
each
kinds of
time, yeah.
combinations of that. You can do as many parallel and series stacks. So you can buy a single pack of springs and be able to dance around if you have space on a screw and say, oh, well, I'm going to try these. And you can try all different total forces with them. And there's calculations for getting what the actual force is on a spring design, which you typically don't need, but to see what they would be. The only thing is you don't want to get them totally flat. You always want to have a little bit of non-flat.
My whole life is based on flat, Robin. I try to get everything flat.
Yeah, right.
So
That's his whole world.
my whole world. You just, I don't know if I don't even know what to do anymore. So, how old is this? Is a tangent, but Belleville must be a guy who invented it. How many years ago was that?
He was Joseph Whitworth's brother.
They played in the same band.
No, they went to the University of Birmingham together. So,
Oh, there you go. Okay, we'll
no,
take
I'm
it.
just joking. I'd see if you guys would swallow that. So,
Which why? Are you kidding? At this point, after all this, so Oh wait, Evils has reported. He says the Belleville name comes from the inventor Julien Belleville, who, in Dunkirk, France, in 1867, patented a spring design which already contained the principle of the disc spring.
wow, that's not too far away. Yeah.
That's well, this is awesome because you guys went from what the hell is Spencer talking about to a finished, nearly finished design, or at least a design ready for prototyping and testing,
Yeah.
and that's pretty cool.
So now the interest, maybe an interesting offshoot of this would be to throw that design away and do a second version, right?
Yeah.
But the problem is that we know the problem now, right? And I don't know if you
Well,
wanted another horse in the race, right?
So if this was a commercial situation and we had a customer who this would be the time we would go back to the customer and say, you know, let me run something past you, and maybe
Sure.
there's
Mhm.
something we missed.
Yeah.
And the customer's going to say, "Oh, didn't I mention it has to be completely non-magnetic?" Just as an
Right.
example, okay.
Mhm.
Um,
Well,
and-
yeah, I mean, if we were a consulting firm, for example, or whatever, right? What we would do is um, a CAD model light, I would call it, right? Okay, not fully fleshed out, right? And then you would go back to the customer and say, "Here's where we are," right?
Mhm.
Um, and our policy at that stage was you want to avoid when you don't have a contract. Let's say somebody approached Robin and myself, and we had a consulting company, right? Is they stated their problem, and we said, okay, let us think about it a little bit, right? And then we go off and we whiteboard and do what we did, right? Okay, and then we're like, well, okay, let's do a quick, let's spend an hour and we'll do a quick CAD layout and make sure that there's no gotchas in here, right? And and then you would go back to the customer and they say, oh yeah, that's good. I forgot to tell you about this, this, and this, right? Well, that's the point where you would initiate some kind of contract. Okay.
Mm.
It's like, well, if you want to go further with this, we don't work for free, so you're going to have to pony up a few hours of design time or whatever, right? And you initiate a small contract. And hey, from that, we'll be able to estimate the manufacturing costs and we might have a 3D printed model for you to play with, right? And that's how you set the hook from a business standpoint, right? And get them to pony up with some a commitment, right?
I think it's important. You bring up a really good point, and I think this the problem process is not necessarily just for fun. It's for business, and we have to do some correct business things.
Well, that's right. Yeah.
And I think that's a really fair point. I mean, we got a lot of guys who are hobbyists, but we also have some guys who are in business, and you don't want to give away the farm. You want to.
Well, this is exactly true, right? So Robin and I could nerd out on a problem like this for weeks, literally, right? And not get any work done, and then go back to the customer and they go, "Oh yeah, I decided I don't want to do this," right? And then we're like, "Shoot, what do we do now?" Right? We just spent 2 man weeks of effort, right? And we got nothing to show for it, right?
Right.
And and I've seen this many times, is people are very, very good technically, but they are not so good business wise, right? Okay. And right.
Guilty as charged.
Right. Well, I don't know. I think is John Saunders on this call?
He had a. He said he's in Discord still. I don't know if he knows that he's in
Okay.
Discord still.
So, he didn't start out as a machinist. A lot of people don't know that, right? And he started out as an accountant, or right? He went to accountant school or
Well,
whatever, or
business
money
school. He went to
school,
money school. Yeah.
business school, yeah, money school, and so I admire how he runs his business, right? He does payback analysis and amortization of equipment and all this, and he's a pretty smart guy that way. So, and his business has been pretty successful, I think. So, to show for that. But,
I think I'm going to suggest that we bring the plane in for a landing. We got a dry runway and enough fuel to complete at least one missed approach. So we should probably execute. You guys
well, that was fun. Yeah.
Yeah.
It was fun. And
Yeah.
I think we learned a little more for next time. And there will be a next time. We'll figure out what kind of schedule we can do. So everybody could stay tuned for the problem process number 2, which will be coming up in a period of time directly proportional to how long it takes us to recover. Any final questions? Anybody? Go ahead, Robin.
Thanks for providing the platform for us to do this on.
Yeah, this worked pretty good, I think. Yeah.
My pleasure. The Zoom features, I think we're getting good at it. We're starting to understand the buttons and everything, and the fact that everybody can give us real-time feedback has been great. And the wisdom, that you guys brought to the table is tremendous. I think anybody who's watching this on video or even listening to this as a podcast, you're going to want to listen to it again or watch it again, because there's some nuggets in there that are fantastic. So on behalf of it, go ahead, Robin.
One thing I just want to mention is this was somewhat easy in the sense that this is right up our alley.
Yeah.
So you can change the complexion of this drastically on the next one by picking something that is somewhat related. So we're not talking about, designing a medical instrument for brain surgery or something, unless we get all the information we need. But but something where it's completely out of our normal realm would change the flavor of this completely, because this was our bread and butter stuff here. This is stuff we work on all the time and very familiar with.
There's lots of examples in industry to draw from and whatnot, right? And where things get real interesting is when it's a problem that it hasn't been solved before, right? And maybe that's something to think about if we do this again, right? Is something completely out of the blue, right?
Yep.
We used to get a lot of requests for odd scientific equipment that
that's only because there are odd scientists.
Yeah. Well, the company that I used to manage and built scientific test equipment, and I mean, we joked around, right? As we never knew what was going to walk through the door, right? And they had a lot of product lines, and they wanted to study a lot of different things, right? And one was, measuring the amount of ammonia emitted from different cat litters, and so we had to find out where you buy cat urine, and then develop a sample holders and a robotic system that moved a probe that was sensitive to ammonia between the different containers and things like that, right? Where it's like I said, you never knew what was going to walk in the door, right? And but it all starts the same. You just start thinking about it, then you get a little edge that you can start working with, and then you get in a little farther, and things start to make sense, and then it's all becomes nuts and bolts at that point, right? Things that you're familiar with.
Well, I'm pretty sure that I'm not going to be the only one tomorrow calling McMaster Car and asking them for a part number for cat urine.
Yeah, urine.
But
yeah.
I know it'll be traceable.
It's pretty expensive, by the way. So.
It depends on the cat.
Yeah, no, that well, okay. Now you touched on it, right? They
No.
have to train the cats to pee in stainless steel pans, and which is no small task, right? And then my recollection, it was for 50 cc's, it was hundreds of dollars. So side business opportunity there for you.
I never, if you would have asked me to name the topic that we would never ever touch on, this would have been on the short list. Well, we would never talk about how to get cat urine. Well, that's gone now.
All right,
gentlemen, thank you so much.
Gentlemen.
We'll talk to you
fun.
soon. Really, from the bottom of our collective hearts, thanks for sharing your wisdom. And we'll see you again soon.
Robin, always a pleasure. Thank you. That
Same
was
here,
fun.
Tom.
Yeah.
Yeah.
All right, guys. I'm going to sign off. I'll see you guys later.
Take care. And I want to say thank you to everybody who came and enjoyed. This was a fantastic experience. We look forward to doing it again. 2 Guys and a Pencil, the problem process number 2, coming up when you least expect it. In the meantime, don't forget to like, subscribe, do all that stuff. If you need something flat, head over to PFGstones.com. If you want to know how to subscribe and see all of our past videos, go down to, there it is, PFG.Live. It takes you right to the playlist. So from Windham, New Hampshire, where it is no longer snowing, this has been Spencer Webb. Get flat, stay flat. We'll see you guys soon. Thanks a lot.